Hey guys, welcome back. Today we are talking about combustion reactions. So remember there are 5 reactions we have to know how to identify and balance. There's synthesis, decomposition, combustion, which we're going over today, and then single replacement and double replacement. Today we are only focusing on combustion reactions. So our lesson objectives are on the screen and we are going to go ahead and get started. Today we are going to learn what a combustion reaction is, what reactants and products go into a combustion reaction, and then of course how to balance them. So what is a combustion reaction? It's just anything that produces heat and light. So in that engagement video you guys watched today with the whoosh bottle, that was a combustion reaction. Charcoal grills, propane gas grills, gasoline in cars. Our cars, most of them, unless you have a Tesla, runs on a combustion engine. Wood in a fireplace, butane lighters, anything that catches fire, essentially. Catches fire, does combustion, creates heat and light. That is a combustion reaction. And combustion reactions are used in energy production, unless it's uranium or renewable energy. Our combustion reactions is really what fuels our energy sources or our electricity sources across the planet. So today we're going to be talking about complete and incomplete combustion reactions. Now I do just want to start by saying most of the time we will be dealing with complete combustion. Like when you see problems and it doesn't tell you, oh, this is complete or incomplete, we're going to assume it's a complete combustion, but I just wanted to make sure we were aware there are 2 different types. Complete combustion reactions, basically it just means it has enough oxygen, so it completely oxidizes the carbon that's the fuel source. And in an incomplete combustion, there's not a good oxygen ratio, so it's not completely oxidized, and there are some problems with that. So here is what we need to know. Oxidation reactions, they're also called redox reactions or a reduction oxidation reaction. The way that we're going to be able to identify this is that the reactants and the products will always be the same. Okay, and what I mean by that, it's easily identifiable because oxygen is always a reactant, meaning that O2 is always going to be on the left-hand side of the equation. Remember, oxygen is one of those diatomic molecules. It always exists together with itself or bonded to another atom. So oxygen, O2, will always be on the left-hand side of the equation. And then the products are always going to be carbon dioxide and water. So that's how we're going to be able to identify this. Also, if you have like a word problem and it says something is burning or something ignites, that's going to be our indication that a combustion reaction has taken place. Also, the fuel source for combustion reactions are hydrocarbons. That just means you're going to have some fuel that has both carbon and hydrogen in it. That's really the only kind of variation we will see in these problems is the type of fuel source. So here's our examples. In the left-hand column, we have an example of a complete combustion. This is when there is sufficient oxygen. And if you were to ignite this, you would see a blue flame color. And this is the equation. So we'll have a hydrocarbon, the fuel source, and now it says CXHY because the ratios that these hydrocarbons are in can vary, okay? So just be aware that will change. But what won't change is that there will always be oxygen on the left-hand side, so always O2. And we will also always have CO2, carbon dioxide, and water as a product. So oxygen and fuel always goes in. Carbon dioxide and water always comes out. Okay, so that's how you can identify a combustion reaction. Next, we have an incomplete combustion. Same thing, it's just in this instance we have a poor oxygen ratio to our fuel. The fuel can vary, it's still going to be some kind of hydrocarbon, so carbon and hydrogen. Oxygen gas will go in as a reactant, and then the only thing that differs is that instead of having CO2, we'll have CO, which is carbon monoxide. So we'll have carbon monoxide and water in an incomplete combustion. That will be important when it comes to balancing our equations, so we have to pay attention to, is an incomplete or a complete combustion reaction happening here? So when we balance these reactions, you're going to balance them the way that you balance all equations, we got to make sure the left-hand side matches the right-hand side. The only difference is that we do it in a particular order with these combustion reactions. So we're going to do carbon first, then hydrogen, and then oxygen. The reason we save those oxygens for last is because just like when we balance a normal equation, if we get to the end and we notice that there's like an odd number of oxygens, we double the fuel and start again. Okay, so if it's not working, we double everything and then start over. So let's take a look at an example. So the first thing I notice, so here is my equation. We have C2H6, that's our fuel, that's a hydrocarbon, plus oxygen gas will yield CO2 and H2O. So here I know I have a complete combustion because it's CO2. And when we do our problems today in your independent practice, we're going to be sure to pay attention to whether it's complete or incomplete. So we're going to start just by balancing our equations like we always do. So we're going to have a C, an H, and an O. A C, H, and O. Okay, so over here I have 2 carbon, 6 hydrogen, and 2 oxygen. Then I have 1 carbon, 2 hydrogen, and 3 oxygen. Now we have 3 oxygen here because there's 2 attached to this carbon, and then there's 1 attached to the water. Okay, so 2 in the CO2, 1 in the H2O. So let's balance our carbons first. So I have 2 on the left-hand side, so I'm going to need 2 on the right-hand side. So I'm going to put a 2 here. I'm sorry, my 2 has to kind of go over this arrow a little bit, but it'll be all right. So now we have 2 carbons and 5 oxygen. So our carbons are balanced, so now let's balance our hydrogen. So we've got 6 on the left, so I need 6 on the right, so I'll put a 3 here, which will now give me 6. But what happens here, my oxygens can't be balanced with a whole number, okay? Do we see how once we get here, we have 5 oxygen, and then we have 2 on the left-hand side? There's nothing we can put here to get to 5 because we can't do decimal places when we are balancing equations. So what I'm going to do is double everything. So I'm going to double the fuel, and I'm going to start again. Okay, so I'm going to just go ahead and erase this. And I'm going to start a new one. Okay, so I'm going to go ahead and double my fuel and then start from there. So C, H, O, C, H, O. Okay, so now I'm going to have 4 carbon, 12 hydrogen, 2 oxygen, and then 1, 2, and 3. All right, so now let's go ahead and balance. Same way, let's do our carbons first. Now we have 4 carbons, so I'm going to do a 4 here instead. We could have kept what we had before and just worked from there, but for me, I like to start over so I can see everything easier. So now I have 4 carbons. 4 times 2 is going to be 8, plus 1 is going to be 9 oxygen. Now let's balance our hydrogens. So we have 12 on the left. We're going to need 12 on the right, so we're going to need a 6 here, which gives us 12. So we're balanced, but let's see. So 6 oxygen plus 4 oxygen is now going to give us or so 8 oxygen, sorry, 4 times 2 is 8, plus 6 is going to give us 14 oxygen now. And we can balance this because we can use a 7 here as a coefficient to give us 14. Okay, so if you balance your carbon and hydrogen and you notice the oxygens can't balance, you just double your fuel and start again. So 2, 7, 4, and 6. And that is what this is. I just did it for you guys as an example. Okay, so that was a complete combustion reaction. Now let's do an incomplete combustion. So in that last one, we knew it was complete because we had CO2 as our product. Now we're going to have CO, which is carbon monoxide. So same thing as we did before. C, H, and O. C, H, and O. All right, so we've got 2 carbon, 6 hydrogen, 2 oxygen, 1 carbon, 2 hydrogen, and 2 oxygen, because we've only got 1 in the carbon monoxide and 1 in the water. All right, let's do our carbons first. 2 on the left, we're going to need 2 on the right. That means I need a 2 coefficient here, which will be 2. Now I have 3 oxygen because the 2 plus 1 is 3. So our carbons are balanced. Let's do hydrogen. 6 on the left, I'll need to put a 3 here on the right, which will give me 6 hydrogen. And now I have 3, 4, 5 oxygen. And same thing, we're going to need to double our fuel up, right? So I'm going to go ahead and double everything. So I'm going to do a 2 here, and I'm just going to go ahead and double my coefficients because you can. So let me erase these. So I'm going to double everything and then come back. So I had a 4, I had a 2 there, so I had a 4, and then I had a 3 here, so I'll put a 6. So now we have 4 and 12. 4 and 12. And we still have 2 oxygen on our left, but now we're going to have 10 oxygen on our right. And so we can have a 5 right here. So it should be 2 C2H6 plus 5 O2 will yield 4 CO plus 6 H2O. And we have 4 carbons on both sides, 12 hydrogen, and then 10 oxygen. Let me put the 10 here. Okay? And so again, this is just to demonstrate. These are pretty straightforward. You balance your carbons first, then your hydrogens, then your oxygens. If your oxygens don't balance, do what we always do, where we double every coefficient and start again. The only thing that can get tricky is over here. You have the oxygens in both the compounds in your product. So whether it's CO2 or carbon monoxide, you'll always have oxygen in 2 different compounds. So just be sure when you are adding your coefficients, you're keeping up with your number of your atoms as you go. Okay? And this is just the steps that we just went through in a very neatly ordered way instead of me trying to draw on the screen. Okay, so that's an example of an incomplete and a complete combustion. You just have to be able to identify the reactants and the products and be able to balance. You guys will do some practice, of course, today, but if you have any questions, let me know.